All right, so we'll be discussing about Spark SQL. Okay, so what is Spark SQL? Right, SQL has been one of the leading query language across the data engineering stack. Right, so some of them when people like work with wanted to work with the Spark. So Spark SQL extends if you are from the SQL background to, do the interactive queries and work with the big data analytics. Okay, so if you're good in Python, which is well and good, but otherwise it doesn't stop. You need to learn Python and to interact with the data only. If you are good at even SQL, either you are good at MySQL and all, you can work with and interact with the Spark shell to to run some kind of a queries and get that some insights. Okay, and of course, yeah. So Spark SQL again, SQL is one of the backbone of data engineering, right? Without SQL, nothing works. Either you are from a data analyst background or the data engineering background, SQL is must. Okay, and also it integrates easily with other Spark services as well. For example, machine learning, right? So if you want to run a machine learning model and all, it's very easy to integrate with other services. Okay, now let's question to you guys. How many of you know SQL? All of you know SQL?
No, sir, I don't know SQL.
You don't know SQL. What about others?
No, sir.
Hmm. Okay, so if you are new to SQL, don't worry, it's not a too complicated language, but spend some time to learn, right? At least the basics, select, insert, delete, and some of the joins. Okay, spend some time to learn that. It will be very helpful to understand and work with the Spark SQL. Okay. Now, if you remember the architecture we've been talking about, right? So this is the Spark core, which is written in multiple language, and there is an API layer where we have different machine learning, streaming, and SQL. SQL is for interactive queries. Okay, and also we have a graph and so on and so forth. So the reason I want to bring this slide is because just wanted to stress on what is the importance of SQL in working with Spark. Okay, so now the interactive queries could be in the form of data frames, RDDs and all. Right? So either Python or you can do it in a SQL as well. Okay, so now why is Spark SQL? Because it's very expressive and easy to understand query language, right? As I said, you simple, that select a table, select columns, and from the table, that's it. And you can go the where conditions and all, right? And also it support multiple complex queries as well. You can do groupings. If you have data coming from multiple sources, you can join them and then get the insight, right? You can join them and you can group them and you can do so on and so forth. And the third one, which I keep telling you, right? It's handy. If you're from the SQL background, it's very handy. You need not break your head, but nevertheless, if you're new to SQL, learn it because this is a I mean, one of the must to have any developer, right? I've been in this industry for more than 10 plus year, right? So the day I learn started with SQL, still SQL remains SQL. And there are so many technologies, big data, that this everything comes and goes, but they still SQL remains SQL. Okay, that means it's one of the demanding and foundational language for anyone to work with the data. Okay, there may be other technology. For example, when I was learning, Python was not there. Python came recently. right? And there are many other languages that came recently, but SQL remains still SQL. Okay, so that's what I wanted to stress on. And then it's also supports, you can tune the queries and you can optimize, right? And performance tuning and all is available. All right, so another big advantage is schema on read. Okay, so what is schema? Can somebody answer what is schema? I think we discussed and have done a lot of stuff with schema when we're creating RDDs, when we're creating,
Schema is a
data
structured
frames.
collection of database.
Sorry?
Structured collection of database.
Correct. So what is the structure? It's basically the column names and the data types, right? So what is schema on read? So that means, let's say I got a, uh, let's take a similar example. So schema on read means, let's say that this is my employee data set, right? I've been working with the client and the client had sent that employee data set. Okay. Now, until I read this one, I don't know what is the schema of this data set, right? For example, employee ID, name, salary, department, and some of them are strings, some of them are integers. I only came to know when I read this file, right? Until that, I don't know what is the what are the columns exist and what are the data types and all. Okay, so that is what called schema on read. So while reading, when you read only, you will know the schema. Okay, so this is a very good concept in uh, when you work with the when you are working with a database. You first define the schema and then you ask them, hey, look, in my database, this is what my table. So you need to send the data in this format only, right? So that is schema already exists. The schema already exists and you're asking them to send the specified format or specified schema. But here I don't know the schema, right? For example, customer one sends this way, customer two can have a date of joining, and customer three can have something else, right? That I can only know when I read the input file. So that is what called a schema on read. Did you get the difference? Guys, is it clear or no?
No, sir. Can you come again?
Okay, so now two things can happen. Okay, one is schema on read, another one is schema enforcement. Okay, so let's say that I have already an employee table with employee ID, name, right, department, and date of joining. Okay, so this is what is there in my SQL database, the table. Okay, now let's say that you're discussing with the customer, says that, you want to you have asked him to send the employee data set, right? So now what are the options available? You already have the schema defined for you, right, in the SQL table. That means employee ID, name, department, date of join. Then only you can accept. Anything out of this can be, you don't have any schema for that. Okay, so now when you're discussing them, you both have agreed that okay, they will send that employee data. Now you will tell that, okay, hey, look, This is the schema I have, and I am expecting in this schema. Okay, so now this is kind of a traditional way of doing, right? We have a data warehouses, right, where the schema has already defined, and we know what the employee data schema is, table schema is, and we will send this to them so that they can send only this format. Now what would happen if they send in this format? You will not able to do anything, right? Because you are expecting something, he has sent something, right? It's all conflicting. Okay, now that is where, since we are in the big data world, right? So in big data world, it's very uncertain, right? So the schema and all we cannot define before that. Okay, and one might send one format, and another one might send different format, right? So that is where, when this big data analytics big data process came, it's very difficult to fit into the existing schema. Okay, and it's very highly impossible when we're dealing with the volume and variety of data. You remember the three characters of big data: volume, variety. So variety in the sense, everyone has sending their own way of employee data set. As I mentioned, somebody is sending with the date of joining, somebody is sending something else, somebody doesn't have these two columns, right? It's a very variety of data. So in that case, what we will do, right? We need not break too much of our head to fit into our own existing schema only. That is where there is another concept called schema on read. That means, okay, source one, source two, right? And everyone is sending their own. Like for example, this guy said employee ID, employee name, right? Date of joining and salary. This guy had something else. This guy has sent ID, name, right? Salary. And this guy had something else, right? So that can happen. So now what would happen? Depending on the schema, depending on the source of data, depending on their file, we will create a schema on read. We remember when we creating data frames, we are doing schema on read, right? Based on the input data, based on that we are creating a schema. We don't have a schema upfront to fit into the and then we are adjusting the input file accordingly. We have already input file is there, and then accordingly we are defining the schema. Okay, this is ID, this is name, this is this. We are defining and creating the data frame accordingly, right? So that is the difference between schema on read and schema enforcement. And in big data world, you will be dealing mostly on schema on read. Got it, guys?
Yes, sir.
Okay, so now hope you got what is Spark SQL and the importance of Spark SQL and why it is uh, so important, right? Now let's quickly turn on to our okay, so now let's see that. So this is my Spark. Okay, so what I did, since it's a uh, default was Python, I changed it to SQL. Okay, and the rest of remains same. Okay, so now I let me show. When initially when have show databases, nothing was there. Okay, then I created a database, create database, uh, MyDB. Okay, so now here what is database? Come on, I need some answers. What is database?
Database is nothing but a information.
Okay, information. Anything else?
Collection of
Collection
data.
of data storage.
Collection of data storage. Okay. Anything else? Okay, so I'll give a background. Okay, so let's say all are good. Like information collection of information, collection of data storage, information, everything. All are close to that answers. Okay, so now when I say data, right? So let's say that this is my data. Hmm, let's say that this is my data. You're discussing with the client and say that, hey, give me your data. That then he said that this is my data. Everything is in Excels. Okay, and he sent to you. Okay, so what do you do? Right, you need to read. You need to read, and you need to extract that information out of the each of that file, and you need to understand, and then accordingly you need to organize the data. Right, because this doesn't give you any insight. You cannot read these files like this. Right, this may be a product, this may be a sales data, this may be an employee data, this may be a pricing information data, this is maybe the geographical data, right? So the data is there in different formats. Okay, and then when, let's say that today he had one one store in maybe in US or India somewhere, right? And tomorrow he has grown to across the globe. And what would happen? He had thousands of stores. Now what would happen when the thousands of stores happen? What will happen? Obviously data grows, right? Now what would happen? This will become thousands of files. Now it's in the tens and hundreds. It will become a thousands of files, right? Now it's very ambiguity, and it creates very ambiguity, and which creates very it's not a scalable, it's not a manageable, right? So that is where the database management systems have come. Okay, now what is database is organizing the data, okay, in such a way that can be uh, uh, organizing the data in such a way to cater all the kind of needs. That means somebody can query, somebody can update, somebody can delete, somebody can uh, do some analytics, right? Anything they can do. Okay, similar example, if you see, let's say that this is the pricing data, right? The a product of the price is updated today. So now what you need to do, wherever that product being referred, you need to update all the, you need to manually go back and check each of those files and update that, right? Remember how difficult the task. And you have thousands of files. You need to open each of that files and do that. It's, I mean, it's not a efficient way, obviously, right? That is where these database systems have come into picture. Okay, so now how how they manage the data in the databases. There are so many databases. You would have had that, right? You have a Oracle, you have a MySQL, you have a uh, MongoDB, you have a Cassandra. You would have had so many databases exist. Okay, and each one have their own purpose, right? It's not like, one to replace another. Okay, now how this information getting a stored in the databases in the form of tables. right? So out of these hundreds of files, I might segregate. Okay, there is a product information is there. There is a customer information is there. There is a geographical information is there. There is a pricing information, right? So these all files can be segregated into these categories, right, in the form of tables. Now that product information will have all the products sold by that organization. Customers, all the customers, right, who are buying or selling the products to with the interacting with that organization. Geographical information, the the country, all the countries that they operate. Pricing, pricing of all the products, right? So now this is the efficient way. Now tomorrow a new product comes, you may not look for all the files and then update the new product, right? You just go and create a new record it over in the products, right? And customers often, right, daily hundreds of customers keep adding, right? So you need not go back and update each of those files manually and do that, right? You can go customer table and add that customer. Similarly, geo and pricing, right? So this is easy to manage and scalable. The main object is scalable, and it's a scalable. Tomorrow you can have a right. Today you have 100. Tomorrow you can have thousands products as well, or 10,000. Right? Customers today you have 1,000. Tomorrow maybe 100,000. Sorry. Right? Tomorrow you might have 100,000 customers. Right? The scalability is important. That is where these database management systems have come. So database database management systems are basically managing the data in a such a way that can cater all kind of needs into querying, updating, deleting, and also doing some analytics at scale. Okay, so now does it make sense, guys? What is the database now? You guys understood?
Yes, sir.
Are any questions? Okay, so similarly, when we work with the Spark, right? It's not always you get these kind of files, um, different, right? You may be dealing with employee, right? You may be dealing with sales. You may be dealing with the what do you call payroll or any other, for example, finance, right? So these are the different databases. Now within employee, there could be anything like you have a employee information, right? Department information, you have a salary, or different departments, or payroll, right? All these are becoming tables. Now sales, within sales, you have a daily sales, you have a pricing, right? You have products, you have customers. Okay, similarly in finance, right? You have a accounts, you have a deposits, you have a withdrawals, right? So on and so forth. Okay, so these information will become a, you need to the most granular level you need to bring. You remember, you need to cater all kind of needs. It's not a one specific, I just wanted to do this and I quickly I create a, it's not a one specific case. You need to, while creating this database and while creating table, you need to keep in mind to cater all kind of needs. Somebody might query, somebody might do some update, somebody might do something, right? And it should be able to do that. Okay, so now let's go back. So now I have created a database called my database. Okay, so now if you see, so database is showing the database, it's the default one, and then I created a my database. Okay, so now let me in the my database I want to create a table called employee. Okay, simple table. Okay, so then now what I will do, create table name, right? Table name employee sample. Now what and I will have it ID integer, name string, and then salary integer. Okay, so let's create only with these three columns for now. Okay, now see what and all happens. So there are 4 jobs have been created, right? So if you look at this one, okay. So now how do I check whether my table is created or not? Show tables. Okay, so now you can see uh, is created in default database. Okay, why? Because I didn't mention I have 2 databases, default and MyDB, and I just created a table. I didn't mention which database I want to create. So it's by default it went to default, right? So now I want to create a table in MyDB only. What I need to do, I need to just use MyDB, okay, and then create table. Okay, so okay, now I can create a table. Okay, now if I do show tables, you see the employee tables got moved to MyDB. Okay, now there is another option. If you see is temporary, the value is false. Okay, why it's false? What is temporary and why it's what is temporary and all we will discuss in further classes. Don't worry, right? But this is a way you create a database and then you create a tables and then you load the data. Okay, now let's say if I want to see what is there in my table, I can see select star from EMP sample. Right now nothing is there. Okay, and if you remember while doing ADF, right, in the Azure Data Factory, we created a SQL database and we run some queries, right? So the same stuff over here. So there the schema, everything is the visual is already available. So it was easy, but here nothing is there. You need to create your own, right? So if you see select star from example, nothing is there. Now let me insert some data, right? So I need to give values. ID could be 1001, name could be John, and salary could be 10,000. Okay, now you see when I created a inserted a record into this, number of FA 1, number of inserted rows 1. Okay, now if I see select start from employee table, you see there is a one record, right? ID I just inserted, name and salary, right? So this is the way when you manually create the data. Okay, now uh, so now in this example, I just created a sample table and I just want to show you. So I just inserted a manual record, right? So now what would happen if I, let's say you got a employee data set from your source, right? And there are hundreds of thousands of millions of employees are there. So how do you uh, create a table out of that? You cannot do manually one by one, definitely, right? So what other options we have? Okay, so that is where you mentioned, yeah, if you remember, let me, okay, okay, let me open. Not this one. Okay, this one. Okay, so now if you see, I have a CSV file, right? And I want to create a data, create a table out of this. Okay, so what you can do is you can upload this file, which is already available in our data, right? If you see, the file is already there. Okay, and then you can create a table using CSV. Okay, for example, I have create table. So this is manually doing, and if you see what we have done is a manually, right? And I just wanted to show manually you can create a table and you can create a schema and then insert the data. Okay. Now tomorrow, let's say you want to update and you want to delete, you can do so on and so forth on this data. Now let's say that I got this file, right, with the millions of data. Now I cannot insert one by one, right? So what there is another option. What we can do is upload that file into DBFS, okay, and create a table out of that. So this is where it is called schema on read. Now, if you see here, I defined that schema, right? For example, see ID, integer, name string, salary integer. I defined that schema, and I manually input the data according to this schema, right? So now with the CSV file, I got it from the source. Now I cannot create manually and insert each of this one. I cannot go and open and read and create the schema and do that. So what I can do is directly I can upload, right? Create table employee data using CSV. Okay. And then options, I can give the path of that file, and I need to mention header equal to true. Since I have a header, I can give the header equal to 2. Okay. Now let's see, let's create this one. Okay. So okay. Now you see all the data got created. Okay. Now if you see it over here, I don't know why it is not showing. It's saying compute is not available. No cluster, but I have a cluster. I don't know why it is saying. Okay, I need to figure it out. Okay, so the database tables, whatever created, you can see it over here. Okay, let me figure it out. I will come up with why it's not showing here, though I have a cluster. Yeah, okay, we will come back to that. Okay, guys, so now you can see I have created a table out of CSV file. I need not break my head, defining one by one column like ID, name, this, that. I need not break my head. I can just give in the file accordingly and then give the header equal true. Now you see all the uh, columns are automatically created. Okay. Now I can update, I can delete, I can do whatnot, right? For example, let's say I want to increase the salary to 15,000 for employee ID 1001, right? Now I can update EMP data set salary equal to where EMP ID equal to 1001. Okay, so this is the delta sources. Okay, update, you cannot do update. Okay, so what is delta? I will come to you later. Okay, don't worry. Okay, so now let me do one thing. Now this is available data, right? Now I want to do I want to calculate, select department wise, right? Department wise sum of salary, right? And max salary, minimum salary, right? And I can do anything and count star, right? From EMP data group by department number, right? So you see, then I got some salary. Now the same thing when we have done in using a data frame, right? You had to use aggregate function and you need to call, you need to give an alias and you need to call different after within that aggregate you need to call different uh, aggregate functions, right? But if you see the same thing can be done easily over here. Now you can give alias here as some salary as, and you can give as max salary, minimum salary, and is as count. See, so this is the beauty of working with SQL when you have a structured data. Got it, guys? Got it, the difference between Python and SQL?
Yes.
So now if I want to add a new column, what I need to do in Python, I need to have a with colon and define that column and then do that, right? Here I can alter the table, add new column, I can do that. I can alter table EMP data, add, for example, date of join, date, right? It will add a new column. Okay, add column is missing. You see, column, new column added. Now if I query, this is the new column. Okay, so now that's how you need to work with the SQL. Okay, so now tomorrow we are going to work with some of the functions available. Now if I show functions, right? You see there are a lot of functions are available. Okay, right? If you can get absolute value, you can get add months, you can get any values, and you can work with arrays, and you can work with let me say average, right? Just now we did average, boolean, case, seal, or characters strings, right? Conversion strings, concatenation, everything. You can see there are hundreds of functions available. You can see almost 500 are available. You can work with timestamps. What are the timestamps you want? You can do that. And you can work with conversion to char, to number, to JSON, right? All this can be done. For example, you see if we just use sum, right? Sum is there, right? Substring, standard deviations, all this can be applied and you can do that. Okay, so now tomorrow we will work with some of the functions that which is very important and they are very much useful in day out. Okay, now which one easy? Python is easy or SQL is easy?
SQL is it, sir?
SQL is easy, right? Yeah.
Yeah.
So, but see, I definitely SQL easy, and it's a more fun when you work with SQL. You feel that I'm doing something. From my experience, I can say that. Okay, but that doesn't mean that Python is bad. Okay, when you get into such a situation where you have to use both.
Yes.
Okay, right. So it's very important to uh, understand both. It's not one is a replacement for another, right? Everyone has their own advantages. Okay, so now what I want to do is, yes, if you are as many of you know to SQL, spend some time to learn basics of SQL. Okay, there are a lot of uh, content available, right? If you type, there are a lot of country, there are W3 school and all, right? SQL introduction. These guys teach very, very, layman terms. Okay, spend some time understand what is this one, right? This will help you not only to understand this Spark SQL, but in your career as well. Because without SQL, you can't make any progress. SQL is a kind of a bread and butter. Now, if I have bread and butter, then only I can have a lunch and dinner, right? Without bread and butter, I can't move to lunch and dinner. Okay, this is my recommendation. Python, it's okay. You can learn over this one, but SQL, as a data analyst, as a data engineer, you have to must. Okay, go and understand. It is not a is a huge content or anything. It's very good. You can see the same. We use, right? Select, how select works, right? It's syntax, select column name from table name. That's it, and that's what we did it over here, right? Select column name and from table. Okay, it's very good. They tell you each layman terms, and they tell you why, what, and all. Okay, and you see all these options, right? You can create a database. What is database and all? Okay, maybe creation database and all fine, but at least you need to know all these SQL commands. Okay, you may not creation database you may not create at the day one, right? That you can learn over the period. But the SQL syntax and all, SQL, what are the difference? See, these are only the functions: count, average, sum, right? That is what we have seen right now. If I see it here, count, average, sum, they all exist here, right? So spend some time. So you need to definitely, you need to learn from your career perspective. You need to learn this SQL. It won't take, if you ask me, hardly 2 or 3 days of job. But over the weekend, you can learn it as well. All right, guys.
Yes, sir.
Yeah. Any questions? So tomorrow we'll be working with the more the functions, and you do how do transform the data, and so on and so forth. Okay. And then after that, how do we use both Python and SQL in your notebook? That's even more interesting. Okay. And after that, so once you create this one, right? How do you run this notebook? Right? We need to run. You cannot run manual in production systems, right? So now, how do you integrate this Databricks notebook with the EDF pipeline? Okay, so with that, I think we are pretty much close to completing this Databricks. Okay, and then we'll have question and answers. I think some of you have some questions we will discuss. So now the exercise is learn SQL from W3 school. Okay, let me ping you the uh, link it over here. Okay, and also from the previous exercise, if you have any questions, you can come up. Okay, so yeah, that's all. Anything, any questions? So how it is so far? Is you guys feeling too much, or it's okay, or what exactly? See, you are in the learning phase, right? And I always used to say it, right? So if you work hard now, okay, in future when you really get into a project, you will it is going to be easy, right? If you don't work hard now, right, what would happen when you get into the project? You need to work hard. Okay, but work hard remains same whether you do now or whether you do later. Okay, but there is no shortcut. Okay, guys, that's what I wanted to give you an update.
Yes.
It's it's like you're preparing for a war, right? So if you practice now, the war going to be easy. Otherwise, you you have to there you will get very less time to practice. Right? Because when you already somebody is um, uh, threatening and somebody is fighting against you, there you cannot practice, right?
Yeah.
Yeah. So the simple example makes sense, Sunita.
Yes, sir.
See, that's how this industry works, right? It's not whatever we learn the engineering, whatever the 4 years we done, that's not enough, right? So we have to be keep upskilling ourselves, and technologies are evolving daily, right? The moment you try to learn something, for example, Python some 3.11 is there, right? So the moment you try to learn Python 3.11, tomorrow some Python 3.12 would have come, right? But that doesn't mean that some of the things you can learn on job, right? But the basics and the foundation skills you need to develop. That's what I'm trying to say. Okay, I think we are good. So let's resume again to understand the built-in functions available in SQL. And definitely SQL is more interesting, and the more you work, the more it's interesting. Okay, so um, we'll have let's resume tomorrow again. Okay,
Okay, sir.
all right, guys, have a good day.